Okay, welcome everyone, and thanks to RustConf for inviting me. As you know, Rust is growing within Linux. Here today, I want to briefly describe the Rust for Linux project. We have heard a lot of things in the past 2 weeks around it. So I hope with this keynote, I can clarify a few things here and there. So let's get started. First, let me give you some perspective on the kernel. I think with this context, you can understand better the extent of what we want to achieve with the project and the implications of that. So the kernel is a big project, and you can see the Linux kernel as a project of projects, really. Let me show you some concrete numbers for the last release cycle, which typically takes 9 or 10 weeks. So for version 6.10, we had quite a few thousand commits in the kernel, about 2,000 developers contributing in that cycle, 240 new developers joining and making their first kernel contribution, 200 companies that supported in some way the work in the kernel, and about 1,800 unique kernel maintainers are listed in the maintainers file in the kernel. So with that, let me continue with a bit of history of the Rust Linux project. So there were some efforts that I am aware of. Several people have had the idea of writing out of 3 modules for the kernel. The first one that I am aware of is from 2013 by Taeso Kim, and I think it was before the Rust 1.0 release. Now, Rust for Linux is not really about out of 3 modules. In fact, it's quite different, and we will see later. It's about getting Rust support into the mainline and making it usable for anything you would use C, not just for out of 3 modules, and we will see later. So I created the Rust for Linux GitHub organization in summer 2019, but it was not really used until the next summer, when there was a Linux kernel mailing list thread in July 2020 expressing interest in Rust. It was sent by Nick Desaulniers and CC and a bunch of us. And then from there, we went to give a talk in LPC, in the Linux Plumbers Conference that year, called Barriers to In-Tree Rust. All that mailing thread and the talk that we have at Linux Plumbers and the conversation made me realize there were a few people that wanted this to happen. It was still pretty much a pipe dream at that point, but I thought it would be useful to at least get all the people that had all these ideas and they were writing some abstractions here or writing a prototype in another place, in a single place. So I wanted to have everybody in a single place and start the ball rolling because they were working independently. So a few days later, I submitted the first Rust for Linux PR to the repository. I included the Kbuild integration so that you could have modules in tree, not out of tree, but actually in tree and built-in modules as well. And so that the standard library, core analog, was shared across all the modules, rather than having core analog duplicated in every kernel module. It also included the beginning of what we call the kernel crate, which was essentially where we put all the abstractions, all the sets of abstractions for the entire kernel, essentially, and contained the Alex Gaynor and Jeffrey Thomas work that they did in the past. Soon after, people started really just joining and collaborating, and after some time, we sent the initial RFC to the Linux kernel mailing list as you see there, in 21st. And then 2 years later, the support got merged into 6.1. So, with all that context, I want to answer the question of what is Rust for Linux. And as you see there, the definition that we normally use is Rust for Linux is the project adding support for the Rust language into the Linux kernel. And as you can see, it's quite generic, it's fairly generic. But that's precisely because our goal is quite wide. Our goal is really quite wide in the kernel. So in particular, What we have always wanted to do is full integration of Rust into the kernel. That means first-class support of Rust. So ideally, for anything you would use C, right now in the kernel, you could use Rust. It's primarily focused on in-tree work, not out-of-tree. This is something that we get, this question we get fairly often. It's not limited to loadable modules. Since the very first PR that we sent, we have supported built-in modules. We also serve the abstractions, as I said before, core analog, and so on. It's not limited to drivers or leaf modules. This is something that comes up as well fairly often. The goal, the eventual goal, is that it can be used for core APIs and to write subsystems themselves in Rust as well, eventually. And it's not limited to kernel-space code, because there is other things in the kernel, like we also want to write what we call host programs and user programs in the kernel. Host programs are the ones used during the build. So we want to use, and we already do, use Rust for at least one. And our aim has always been, and this is very important, our aim has been to upstream this support into the actual kernel, into mainline. So a couple more things to clarify. Is Rust for Linux a Rust project? Well, not really. Although some of us in the team, of course, collaborate in Rust, in the compiler, in other parts, and some of us are part of Rust teams. Is Rust for Linux a kernel project? Well, yes, we are part of the kernel, but the project is not really only about the kernel. In fact, you can see Rust for Linux as a project that involves other projects, right? Kind of a meta project, if you will. So, who uses Rust for Linux? That is, what projects out there are using or taking advantage of the Rust support that we have in the kernel. Here you can see the main public ones that are targeting upstream, but there are others that maybe are not public, and there are others that are not targeting upstream, so they don't care to be in mainline. For instance, we were told at some point that someone was running Rust for Linux in space already, and we didn't even know. Some users are already upstream, as you can see in the slide. Some others are incoming soon, or are expected soon, and some others are doing their best to get there. Okay, every user here in this list faces different challenges because every subsystem, works differently. They have different constraints. They have different, rules or set of people that work, companies behind them, et cetera, et cetera. So yeah, those users have different challenges. A few of these, if you see, for example, Android Binder, there a few of these would have a huge impact in the kernel if they make it into production. For instance, Binder, eventually, it could have a user base of billions of devices. So behind all those users that I just mentioned, there are companies. Which ones are those companies? And I have here all these companies listed here support the effort in one way or another, and would like to see more Rust in the kernel. And as you can see, it's a lot of big users, right? Or a lot of big names. Now, how do we use Rust in the kernel? Does it look different from normal Rust? Well, obviously, the kernel has some special needs, and it turns out that, it in turn means that our use of Rust in the kernel may look strange a bit from the outside. For example, as you see there, the project directory structure is different. We use a custom build system. Some code that you may see in the kernel tree, Rust code, may look different from what you would do in the user space, and so on and so forth. One thing, of course, we do is interact a lot with C. So for drivers, for instance, this slide is about drivers. This is the general approach we follow, which is, I would say, fairly standard in the Rust ecosystem. Essentially, what we do is we require that drivers have to call safe abstractions, and those safe abstractions currently in the kernel crate, what we call the kernel crate, are the ones that can interact with the C side of the kernel. But otherwise, you are forbidden to call directly the C API. I mean, there are always exceptions to rules, but they need to be justified. That's the point. Also, and briefly, because we don't have a lot of time to get into that or to delve into this slide, but this is how the crates, the current crates in the kernel look like. This is changing. For instance, soon the alloc crate that you see there, we use currently the alloc crate from the Rust standard library. But soon that will be crossed, and we will have our own alloc crate. And the kernel crate that you see there, that is quite big now, will be split into many other smaller crates. We will do that soon. Now, one big example of peculiarities of the kernel, right, is the unstable features that we use, of course. We use a fair amount of them, not just in the language, in the standard library, compiler, RustDoc, Clippy, etc., etc. So we keep track of all these in our issue number 2. Every time I see this link, probably you have seen it, many of you, but every time I see this link, I think I should have used number 1 for that, but it is what it is. That is how this, it's a bit cropped, but this is how the list, the main list looks like. The top, here is the top of the list, and what we have is links to sublists that refer to other projects that we can get into later. But if you scroll down the page in this list, you see the main list, which contains the things that are implemented as features and that we currently use or plan to use. So the unstable features that we currently use or plan to use. And there is quite a few of them. And then in the sublists that I referred to before, we have, for example, this one for the Rust compiler. And these are intended for things that are in progress or not fully implemented, or etc. And it includes both features that we need and bugs that maybe we have found or we think things that are bugs. And of course, these live lists, these are all live lists, so they may, things get added, updated, reprioritized, shuffle around as time passes. So another thing I wanted to mention about how we use Rust in the kernel is the code documentation. So personally, I really like the documentation, the code documentation in particular. One sub-goal that we have had since the beginning is to raise the bar on a few things. For example, one is formatting. If you have seen formatting in the kernel, the code has a few different styles or variants. It's not completely consistent. So one thing we wanted to do is have consistency in the formatting. And another is what I show you here, which is enforcing that the documentation is there written for all public APIs, and ideally also for private APIs. And there are discussions about that going on. Not only that, we aim to make the documentation as consistent and as readable as we can. We follow some of the same guidelines the standard library uses. And over time our plan over time is to add more, more lints and more checkers or other things to enforce all of that. Nowadays, we have also, as you see there's the link, we have our documentation available, at least one particular kernel configuration, at least for the moment, at rustdocs kernel.org. One thing I wanted to note is that we are using the jump to definition feature flag, which makes it feel way closer to cross-referencers like Elixir, Boolean, etc., that are used for the C side. So that is a feature that we think is great and is very useful for us. And that is how the front page of that link looks. Another thing is testing. There is way too many things to say about testing. There are entire talks about testing the kernel. But one thing we do, that we already do, and that I really like, is that our kernel code documentation examples are tested. Of course, in RustDoc, you do that. But in the kernel, we cannot just run it in the user space. So unlike that, we need to run those tests in the kernel. So we transform the tests using RustDoc and a bit of a hack into KUnit tests. Okay, we put it into the kernel framework to do that. And then in that example, in the log that you see in the slide, you can see an example of how the output looks like. That's all the KUnit framework, and it's executing the Rust tests in the documentation. We want also to expand, we are planning to expand this into hash tests, integration tests, other things. And personally, I really like writing tests close to the code, and writing documentation close to the code as well. So that's something we are trying to do. Now, collaboration with Rust. This brings me to the collaboration with Rust. As we have seen, we rely on unstable features. And since early this year, we have been regularly meeting with the Rust project. Of course, we also had meetings in the past here and there, but now there is way more frequent collaboration, which is great. It really, really helps. And I would like to thank Sid, Nico, and Josh for their help setting that up. Moreover, Rust for Linux is a flagship Rust project goal for 2024. And the goal is to close the largest gaps around those unstable features that I mentioned. Please watch Nico's keynote later today for more information about that. One particular result that has come out of that work is including Rust for Linux, the kernel, in the Rust CI. So this is intended to catch unintentional changes that break the kernel so that they can be fixed before they even reach an idle. This helps us to decide in version 6.11 to unpin the Rust version. Previously, we were using a single, the latest stable Rust release. And this was unpinning that version and supporting several. It was a top requirement that we got from the kernel side to make Rust work. So that's great to get it off the list. Previously, sorry, I wanted to mention the versions that we support. So right now we are in 1.78 up to nightly. And yeah, so I want to move on contributing. A very common question we get all the time is how to get started. A very good starting point is our webpage. It has a lot of information about that and other things. And in fact, if you read the initial RFC that we sent to the mailing list, it was one of our hopes with Rust to get more people, more kernel developers and maintainers into the kernel. A lot of people from the Rust community have already contributed, and we are very happy for it. This is how the webpage looks. We will go quickly over it. On the left side, you see some subpages with documentation and resources. We have subprojects of Rust for Linux that we host. We also host pages from other projects, such as tooling around Rust for Linux. These pages are maintained by the projects themselves, so thanks a lot for doing that. As an example of a page that we have there, we have Kernel for Rust. They are very good projects, so please check them out. Similarly, we host projects for our main users. They are maintained by them as well. As an example, you can see some benchmarks from NVMe that Andreas updates from time to time, which is great. Finally, we have some external links, and please remember to scroll on the left bar because it's quite long. So back to contributing, I want to highlight very quickly the contributing subpage. This is where you want to go to get started. And as the page explains, contributing to Rust for Linux is not just contributing about the kernel. You can contribute to the Rust itself, for example, on the unstable features. So you don't need kernel experience or C experience to actually help Rust for Linux. So please ping us if you think you can work on something like this. It's great. There are also the projects that are not Rust and are outside the kernel that you see there in the page that you can also contribute. So it would be one thing I would like to take away from this keynote is that to get some people at least to join and help us. So it would be great to have that out of RustConf. And now we could get into ways to contribute into the kernel itself. But essentially, what I want to say is that even if you don't have experience with kernel programming or C programming, you can still contribute. For example, as a reviewer, if you know Rust and unsafe code, you can really contribute. For example, from experience, we have seen putting a Rust expert and a kernel expert together and discuss how to model a new API in the kernel. And even if they don't know the other side well, or they don't know at all the other side, it still helps a lot. And we see that as better documentation, better APIs, etc., etc. So please ping us if you want to help. As an example, Beno from our team was one of the ones that came from the Rust community and really has helped a lot on reviewing and getting better APIs. Finally, I would like to mention, and I finish with this, our Rust for Linux yearly conference, Cangrejos. This is the last slide. This is Cangrejos 2024, just a few days ago. I actually saw Andreas and Darok yesterday wearing the Cangrejos t-shirt. And it takes place every year. It's joined by active contributors in the team, as well as lead of other projects and kernel maintainers and developers. And I wanted to show you this picture to end the keynote, because as you probably have seen in the news, Weston, a Rust for Linux maintainer who was instrumental for the project, decided to retire from Rust for Linux. For me, it was, of course, very hard. But on the positive side, it may be one of those darkest before the dawn moments. In particular, I wanted to assure you that as you see in the photo, the project is going forward. There is a lot of people, companies interested in Rust, in the kernel, being successful. So let's make it happen. Thank you.